Hello friends, welcome to another ATC Double Cut. In today's episode, I want to talk about two blog posts that are related to total organic material testing, specifically for the top portions of a turfgrass root zone. And when we test the top portions of a turfgrass root zone, there's a lot of material that is considered to be thatch or mat, which is living or dead, recently dead, and still undecomposed plant material. And it turns out that this type of material does not get measured in a conventional soil test, because a conventional soil test is measuring soil organic matter by definition, and soil organic matter by definition does not include plant material. So it makes a lot of sense that soil organic matter would not be measuring this plant material. But so much of the turfgrass maintenance work that gets done, such as regular sand top dressing or scarification to remove some of that organic material from the surface, or coring, hollow tine aerification, and removing some of the soil and the plant material that is with it. That type of work is done to manage what turfgrass managers call organic matter. But I try to differentiate with the words that I use, and I talk about soil organic matter being the humic matter in the soil that does not include any plant material. And then I try to use the terminology total organic material when I'm talking about the organic matter in the soil that also includes some of the plant material. So I've got a couple recent blog posts about that. This is the autumn season in the Northern Hemisphere, and I think the autumn season is an excellent time of the year to do this type of testing. So I've recently been doing quite a bit of this testing. And in fact, I was in Thailand and collected some of the samples myself. And that was a couple weeks ago. And I wrote a blog post that I gave the title, "How Much Did the Grass Grow Underground?" And I want to talk through this and explain how just in the past 6 months or so, I've started thinking about how the clipping volume, which is measuring the above ground growth, the amount of clippings that are harvested. So what I've been thinking about over the past 6 months is how the clipping volume is measuring what happens above ground. And it turns out that the OM246, or total organic material testing, that measures what's in the soil, that actually is measuring what happens in terms of grass growth underground. So this was a Tiff Eagle Bermuda grass green that I was testing in Thailand, and I showed pictures of how I cut the samples at a 2 centimeter depth. And I wrote in that blog post, I said, when the samples collected today are tested, OM2 is right now. By OM2, I mean the total organic material at the 0 to 2 centimeter depth. So I said, when the samples collected today are tested, I'll know what the OM2 is right now, and I'll also know how much the grass grew underground. At least I'll be able to make a pretty good guess at it. Now, how can I know from the samples that I collected on one day in November, on a sunny day in November near Bangkok on a Tiff Eagle green, how do I know that that OM2 number will allow me to make a pretty good guess at what the total organic material accumulation rate was, or how much the grass grew underground? I said, how does that work, you might ask? And again, I'll put a direct link to this blog post in the show notes so that you can just check those out, and you'll see a direct link to this post. And you can look at the pretty pictures too and see how I cut those samples at a 2 centimeter depth, and see some Tiff Eagle greens that you might think have quite a bit of organic material in there. And in fact, they do. But I don't have these results back from the laboratory yet. I'll probably do another blog post when I do get those results back, and I will share the information about what the test results actually come back as. So I said, how does that work, you might ask? Well, the change in total organic material over time is part of the answer, because we know the organic material, the what the test result was a year ago, and then we do the test again a year later so we can see how that changed. But that's not the only thing that's involved, because if we added sand to that layer of the root zone, that would have an expected dilution effect, right? Everybody talks about how adding sand dilutes the organic material. Well, if we know how much sand was applied and where that sand was added, and I think most turfgrass managers pay attention to that and keep track of how much sand they're applying. So when you know that, you can look at the sand dilution effect as an expected change that you would have by the sand, and then you measure what actually happened by how much the organic material did change year after year. And from that, you can calculate what the organic material accumulation rate was underground, and that is telling you how much the grass grew underground. So there is a calculator that I've made, the OM246 calculator, which is a Shiny app. It's a web-based calculator that you can access through this blog post, and you just click on that and you can put in your test results data, and you can also put in how much sand was applied. And after you do that, it will calculate the organic material accumulation rate that accounts for both the sand applied and how the organic material changed. And then it also will calculate for you, if you want to pick some date in the future and say at a certain date in the future what you would like the organic material to be in the soil at a certain level, it will tell you, it will calculate for you, assuming that you have the same, actually you can adjust it. So the default is assuming that you have the same accumulation rate going forward, but you can adjust it and say, you know what, I think I'm going to put more fertilizer. I'm going to make the grass grow faster. The accumulation rate may be higher, or I may cut the fertilizer and it may be growing less and have a slightly lower accumulation rate. But I think it makes sense for most turfgrass managers. They've got things pretty dialed in already. So they're probably going to have whatever the accumulation rate is. It's probably going to stay pretty similar for that site year after year. So then you can say, if you're at 6% organic matter and or total organic material, I'm sorry, I should use the terminology that I tried to use. If you're at about 6% organic matter and you want to reduce it, for example, to 4.8, this calculator will tell you how much sand is necessary in order to do that. So that is how that works. And I just want people to be aware of that and to start thinking. I'm thinking about how this total organic material, the OM2, OM4, OM6, that gets measured, where it includes the roots and it includes the stems and it includes the stolons and it includes the rhizomes, it includes the thatch. How this changes over time is actually measuring what's happening underground. So we can have an almost complete picture of how much the grass is growing and how the grass is responding to fertilizer inputs and how the grass is responding to other management inputs and how the grass is responding to the weather at our site at a specific time of the year. All of these things are accounted for, and we can measure how it's having an effect on the grass, both above ground with measurement of clipping volume and below ground with measurement of the total organic material. So you do this type of stuff just one time, like clipping volume, measure it for one day. It's not that interesting. You do the total organic material testing just one time, it's not terribly informative about something that you can actually take action on. But when you start getting the clipping volume over time and you get a timeline of clipping volume and you add that all together, then you can start seeing how much your grass grows, how much your grass grows in a week, in a month, in a year. How much does your best green grow? How much does your worst green grow? How does the amount of grass that is harvested above ground compare to some other places around the world? I think that is interesting information that can help, that is actionable. It's the type of thing that can be used to make a decision to adjust how much the grass uh, may be modified, how the management of the grass may be modified to improve the conditions going forward. And the total organic material testing does the same thing below ground. So that is something that I am thinking of these days. I didn't used to think of this when I first started doing the OM246 testing, but more recently, when I do the OM246 testing, I think of it as this is measuring what's happening underground. Now, these greens that I showed the pictures of in this post, the last time they were tested, which was in November of 2021, it was 11.3% total organic material in the top 2 centimeters. The OM2 was 11.3%. So when I get those results back from the lab, hopefully in a week or two, because the shipping from a country that's on the other side of the world takes a bit of time. So when I get those results back from the lab, those samples are not at the lab yet. Um, I guess I'll calculate what that accumulation rate was, and I will share how much the grass grew underground in 1 year. Let's see, there's another post that's closely linked to this, also a recent one that has the title 2 Soil Organic Matter Timelines. And I dive in here to the different types of test, both of which I think are valuable. And I have 2 other blog posts about that. I link to them in this blog post. I will mention them. I think I've done a couple ATC double cut episodes about these also. Certainly the one that's titled A Tale of Two Tests is one that I think I recorded in March of 2022. That was an ATC double cut that you can listen to hear more about why these 2 tests give such different results. And I've got another blog post called Organic Matter Separation from Turfgrass Soil Samples that explains exactly why they're different. And the reason, if I would put this in one sentence, is this. The sentence that describes why the different soil organic matter tests give different results. Soil organic matter testing does not include plant material. That's why. Okay. So the total organic material test, the OM246, it does include plant material. It includes roots, it includes thatch, it includes stems, it includes below ground rhizomes. The way that I do it, it would include stolons also. So I think that that's the primary difference. Now, another reason is because we're testing at different depths, but the main reason why you get different results is because a soil organic matter test does not include plant material, and a total organic material test does include plant material. So I looked at data from Kea Golf Club showing zoysia and Kori putting greens to show the timeline, to show how these change over time. And this is a chart that I hope you will click through to this blog post to look at. Again, this blog post is titled 2 Soil Organic Matter Timelines. The data from Kea Golf Club has soil organic matter. Remember that the soil organic matter is what does not include plant material. It just includes the humic material in the soil. That is a number on these putting greens from the 0 to 10 centimeter depth. The soil organic matter over the past 11 years of testing has just hovered right around 2%. That would be 20 grams of humic material in the soil per kilogram of soil, 2%. And it doesn't change very much. So when it's not changing very much, it becomes difficult to use that as a way to decide if you need to add more sand top dressing, if you need to manage your organic matter in the soil more. if you might be developing a thatch problem. This test is just not giving you information about that that is precise enough to really be able to make a decision. But starting in 2017, we started collecting OM246 data at this course and showing from 2017 to 2018 to 2019 to 2020, the OM2 went up, up, up. So instead of hovering around 2%, this started at around 11%, and it went up almost to 15% over 4 years. So the OM2 was going up by 10 grams per kilogram, or 1%, year after year after year. And that is an indication that the organic material at the top of the root zone was accumulating faster than it was being diluted, or faster than it was decomposing. This is something that can then be used to say, whoa, this is going up, up, up. And meanwhile, if you would look at the soil organic matter on those same years, that is just flat. That is a number that's just hovering right around 2%. It's 2%, 2%, 2%. And you can't use that to decide, whoa, we need to get more sand down. We need to remove some organic material by scarification, or remove some organic material by coring or something. And then when coring was done in 2020, after the spring sampling, there was coring and extra sand applied to fill those core holes, and the organic material went down in the top 2 centimeters from almost 15% down to a little bit over 12% in 1 year. And what you see with the soil organic matter is the change in that year was actually in a different direction. So the soil organic matter in 2020 was a little bit below 2%, and the average in the spring of 2021 was up a little bit above 2%. So the soil organic matter testing did not pick up what happened, but the total organic material testing did. The OM2 testing did. And I've started explaining it this way in seminars by trying to show both of these organic matter tests together, and try to explain to people that the total organic material testing can be really sensitive to what's actually happening with the growth of the grass, and it can be really sensitive to what's happening with the way that people are managing the grass, and how much sand is being applied, and the type of work that's being done, and so on. But the soil organic matter testing, which I still like to do, I like to do both types of tests, but the soil organic matter testing cannot really be used to adjust the sand top dressing. So the other data I showed is a timeline from creeping bentgrass greens from Hazeltine National Golf Club. And what you see there, if you look at the red line, that is down right around 1 to 1.5%. So from 2020 to 2022, it's 3 years of testing. The soil organic matter is relatively flat. And it doesn't vary much. It's just in between 1.5 to it's between 1 to 1.5%, 10 to 15 grams of soil organic matter per kilogram of soil. The total organic material in the top 2 centimeters is about 5 times as much. That is up around 5%. And it started off just below 5% in 2019, and up to 2020, 2021, and now 2022, over 3 years. What would that be? The 2022 growing season, the 2021 growing season, and the 2022 growing season, it's now up to an average of 5.2%. So it's gone from something like 4.7 up to 5.2. So it hasn't changed a lot, but what that shows is that the soil organic material right at the surface on those creeping bentgrass greens is relatively constant, but it is slightly increasing. And you can also, if you would note, the value in autumn of 2021 was 4.9%. and it's gone up to 5.2% in the autumn of 2022. So the increase was 3 grams of total organic material, 3 grams of organic material in the top 2 centimeters per kilogram of soil in the top 2 centimeters. That is the rate of increase, 0.3% or 3 grams per kilogram. And you see, if you're looking at the chart, if you're not looking at the chart and just listening to this, then I will try to explain it as clearly as possible. It's gone up in the past year from 2021 up to 2022. It's gone up by 3 grams per kilogram. But the other line that shows the soil organic matter, it actually went down a little bit from 2021 to 2022. Now, both of these numbers are useful. They're just used for something totally different. So I would not want to be looking at that soil organic matter number, seeing that it's gone down slightly over the past year and saying, oh, that means maybe we could cut the sand top dressing, because the soil organic matter is not the number that we want to look at when we're trying to adjust to put more sand top dressing or to put less sand top dressing. And seeing that the organic matter in the top 2 centimeters, what I call the total organic material, because it includes the plant material, seeing that that's gone up by 3 grams per kilogram over the past year, and seeing that over the past 4 years, over the past 3 years, that it's gone up over the last 3 growing seasons, it's gone up by 5 grams per kilogram, then my recommendation to the superintendent at Hazeltine was maybe put down a little bit more sand in the upcoming year and try to get that to stabilize a little bit. So these charts are really simple, and I wanted to share them as a timeline that shows both the soil organic matter and the total organic material on the same chart, so you can see that the difference is about 5. It's like a 5 or 6 times difference is typical. So the OM2, the total organic material that includes the plant material, that will typically be 5 or 6 times higher than the soil organic matter, which excludes the plant material, and it's also taken to a different depth. So that is something that if you understand that about the total organic material testing, and if you understand that with the total organic material testing, if you understand that that can be used to measure, to put a number to how much the grass has actually grown underground, how much organic material has been produced underground, and you can combine that, if you are measuring the clipping volume, if you can combine that with how much the grass is growing above ground, and if you know how much sand is applied, and if you know how much fertilizer is applied, I think that is a very powerful toolbox of information that can be used to adjust the work going forward in order to optimize playing conditions and get the best conditions possible. So these things will tell you if you need to put more sand, if the organic matter, I always misspeak, if the organic material is increasing and increasing and increasing, then you probably want to cut the growth rate or increase the amount of dilution and so on. Now, this is a reminder that I have some email newsletters that you can subscribe to. So if you want to get the full text of these blog posts out on the same day that they're released and not wait until I talk about it on a double cut episode, and if you want to, maybe you'd like to listen to these, but you'd like to read them first, you can do that. You can sign up to the ATC blog update by email. All of that information, all of those sign up links are available at the Asian Turfgrass website, asianturfgrass.com. All the links to these blog posts, everything that I talked about, and to that calculator, you will find those in the show description, in the show notes for this episode. All right, that's all I've got for today, and I just wanted to talk about this total organic material and make sure that everybody is caught up with what I've been talking about in some recent seminars and the way that I've been thinking of this over the past 3 to 6 months. I think this is really useful. I'm excited to see so many people doing this testing, and I think we're all going to learn a lot about how to get the absolute best effect from the sand that's applied and make sure that we put it in the right place. Thanks everybody for listening, for watching, and I will be back again soon with another episode. And for now, I will sign off for ATC from Olga, Washington. I am Michael Woods.